So hello everyone, in this question says that a string of length 2 meter long is fixed at its ends. So a string is fixed at its ends. Say this is the two ends and the string is fixed, which is L equal to 2 meter long, and now is driven by a 240 Hz vibrator. The string vibrates in the third harmonic mode. The speed of wave and its fundamental frequency. So we need to find out the speed of wave and the fundamental frequency. Since it is fixed at both ends, so the fundamental frequency or the harmonic mode is given by formula Fn equal to n v by 2l, where v is the velocity and l is the length and f is the frequency of nth harmonic mode. So here the question said that at third harmonic the frequency is 240 Hz. So f3 equal to 240 Hz and the length is given also here 2 meter. So putting in the formula at n equal to 3, so 240 equal to 3 v by 2l. This is the harmonic mode, third harmonic mode. So here n is equal to 3 and the third harmonic mode frequency is given 240. Now calculating for V, and the L is also given 2 meter. So putting 240 by 3 into 2 into 2 and V. So from here V equal to 240 into 4 by 3. So this will be 80. So V equal to 320 meter per second. So the speed of wave comes to be speed of wave is 320 meter per second. Now the question is asking also fundamental frequency. So the fundamental mode of frequency is given by v by 2l, and here we have calculated 320 meter per second and l is given 2 meter. Just putting it and getting the value of fundamental v 320 into 2 into 2, which is 4. So 320 by 4, which comes to be 80. So 80 Hertz. So fundamental frequency is 80 Hertz and the speed comes to be, and the speed is 320 meter per second and fundamental frequency 80 Hertz. Now let's check which option is matches 320 and 80 Hertz. So option B 320 मीटर पर सेकेंड एंड 80 हर्ट्ज. थैंक यू.
सो इस क्वेश्चन बोल रहा है एक रेजोनेंस ट्यूब के थ्रू एयर में साउंड की वेलोसिटी डिटरमाइन करने के लिए किसी लेबोरेटरी में जो है एक्सपेरिमेंट किया जाता है. तो उसमें दो तरह के ट्यूनिंग फॉर्क यूज़ किया जाता है. फर्स्ट जो ट्यूनिंग फॉर्क लिया गया है उसका जो फ्रिक्वेंसी है वो कितना है 512 हर्ट्ज का है, वो प्रोड्यूस कर रहा है. तो जब इसके साथ एक्सपेरिमेंट किया गया तो जो देखा गया जो वहाँ पर क्या हुआ कि जो ट्यूब थी रेजोनेंस की उसको फिल कर दिया गया वाटर से. तो वहाँ पर देखा गया कि 11 सेंटीमीटर नीचे जो है रेफरेंस मार्क के फर्स्ट जो है रेजोनेंस मिल रहा है. ठीक है. फिर इसी एक्सपेरिमेंट को रिपीट किया गया दूसरे ट्यूनिंग फॉर्क के साथ जो कि 256 हर्ट्ज की है, और वहाँ पर देखा गया कि जो फर्स्ट रेजोनेंस मिल रहा है वो कहाँ मिल रहा है 27 सेंटीमीटर मिल रहा है अगेन रेफरेंस मार्क के. ठीक है. तो यहाँ पर हमें बतानी है कि जो वेलोसिटी होगी साउंड की एयर में वो क्या होगी इस एक्सपेरिमेंट के थ्रू. अगर हम निकालना है, जो डाटा है इस डाटा के थ्रू हमें निकालना है. सो जो फ्रिक्वेंसी होती है, अगर हम बात करें कि ये क्लोज ट्यूब होगी, क्योंकि जो ट्यूब हम यूज़ कर रहे हैं वो क्या होगी, एक एंड से क्लोज होगी दूसरे एंड से ओपन होगी कुछ इस तरह से. ठीक है. और इसमें वाटर इस तरह फिल्ड है. तो एक तरफ यहाँ ट्यूनिंग फॉर्क से जब हम फ्रिक्वेंसी प्रोड्यूस करवा रहे हैं तो ये जा रहा है, तो मतलब हम यूज़ कर रहे हैं यहाँ पर क्लोज्ड एंड पाइप या ऑर्गन पाइप का कॉन्सेप्ट लेके यहाँ पर चलेंगे। तो इसके लिए जो फ्रिक्वेंसी होती है, अगर एन फ्रिक्वेंसी की बात करें तो एफ एन की बात करें, जो जनरल इक्वेशन होता है वो क्या होता है, एन वी डिवाइड बाई होता है 4L के। ठीक है, ये एक जनरल इक्वेशन हो गई, जहाँ पर एन की वैल्यू क्या होती है क्लोज्ड एंड पाइप के लिए 1 3 5, मतलब ऑड नंबर्स होते हैं, सेट ऑफ ऑड नंबर। चूंकि यहाँ पर रेजोनेंस की बात कर रहा है, ठीक है, रेजोनेंस ट्यूब है, तो जो फंडामेंटल फ्रीक्वेंसी होगी उसके लिए n इक्वल टू 1 पुट करते हैं। तो f की वैल्यू या f1 की वैल्यू की बात करें तो क्या हो जाएगी, v डिवाइड बाई 4L के। ठीक है, अब ये जो डाटा है इसके लिए हम देखते हैं किस तरह से इक्वेशन बन सकती है। तो फर्स्ट जो फॉर्क यूज़ कर रहे हैं जिसकी फ्रिक्वेंसी 512 हर्ट्ज है, उसके लिए अगर इक्वेशन लिखे तो फर्स्ट इक्वेशन कुछ इस तरह से होगी, लैम्डा वन मान लेते हैं कि जो ये फ्रिक्वेंसी है ये लैम्डा वन है, तो लैम्डा वन इक्वल टू हम यहाँ पर मान रहे हैं 512 हर्ट्ज, और जो दूसरा फॉर्क है उसकी फ्रिक्वेंसी, उसका वेवलेंथ हम मान रहे हैं, सॉरी ये फ्रिक्वेंसी है तो इसलिए हम इसको लैम्डा ना लिख के इसको हम फ्रिक्वेंसी के टर्म में लिखेंगे, एफ के टर्म में। ठीक है, तो एफ वन जो है यहाँ पर कितना है 512 हर्ट्ज है, और एफ टू की वैल्यू यहाँ पर गिवन है 256 हर्ट्ज है। ठीक है, सो लैम्डा वन डिवाइड बाई 4 जो होगा यहाँ से ये आ जाएगा 11 सेंटीमीटर प्लस ई के। ठीक है, ये इक्वेशन हो गई फर्स्ट। दूसरी इक्वेशन क्या बनेगी, दूसरी इक्वेशन होगी अगेन लैम्डा टू डिवाइड बाई 4, क्योंकि सेम सेटअप है, सिर्फ फोर्क जो है चेंज हो रहा है। फोर्क चेंज होने से क्या हो रहा है कि जो रेजोनेंस मिल रहा है उसकी जो है उसमें वेरिएशन आ रहा है। ठीक है, वो पहले 11 सेंटीमीटर मिल रहा था, फिर 27 सेंटीमीटर मिल रहा है, तो इसलिए लैम्डा टू डिवाइड बाई 4 ये इक्वल हो जाएगा 27 सेंटीमीटर प्लस ई के, और ये इक्वेशन हो जाएगा सेकेंड। ठीक है, ई क्या है यहाँ पर, एंड करेक्शन है। ठीक है, कोफिशिएंट ऑफ एंड करेक्शन है, तो क्योंकि दोनों में कांस्टेंट होगा, क्योंकि सेम ही ट्यूब हम यूज कर रहे हैं, तो ये कैंसिल आउट हो जाएगी जब हम इक्वेशन सेकंड माइनस फर्स्ट करेंगे। नाउ फ्रॉम इक्वेशन सेकंड माइनस फर्स्ट। ठीक है, सो ये हो जाएगा लैम्डा टू माइनस लैम्डा वन डिवाइड बाई 4, कॉमन है दोनों में, और ये इक्वल हो जाएगा 0.16 के। ठीक है, और यहाँ पर साथ ही साथ अगर देखें तो हमें दिया गया है कि फोर्क की फ्रिक्वेंसी जो है 512 और 256 है। तो दोनों के लिए अगर यहाँ पर इसको इक्वेशन थर्ड हम बोल सकते हैं, तो दोनों के लिए अगर हम फ्रिक्वेंसी को अगर वेवलेंथ के टर्म में लिखें तो क्या होगा, क्योंकि फ्रिक्वेंसी अगर देखें तो जो न्यू होता है, या इसको एफ से डिनोट करें तो एफ इक्वल टू क्या होता है सी बाई लैम्डा के, तो लैम्डा इक्वल टू क्या हो जाएगा सी बाई एफ के। ठीक है, क्योंकि यहाँ वेलोसिटी ऑफ जो साउंड है हम सी यूज़ नहीं कर सकते, क्योंकि ये लाइट के लिए यूज होता है, तो यहाँ पर हम वी यूज़ करेंगे सी की जगह पर। ठीक है, जो वेलोसिटी है, तो स्पीड ऑफ लाइट की जगह पर हम वेलोसिटी ऑफ साउंड यूज़ कर रहे हैं, तो उसको वी से हम यहाँ डिनोट कर रहे हैं। तो दोनों के लिए हम लैम्डा की वैल्यू निकाल लेते हैं, लैम्डा वन और लैम्डा टू की वैल्यू क्या होगी। तो लैम्डा वन की वैल्यू देखें तो क्या हो जाएगी, लैम्डा वन इक्वल टू हो जाएगा वी डिवाइड, क्योंकि वेलोसिटी ऑफ साउंड तो सेम ही होगा दोनों केस में, तो वी डिवाइड बाई क्या हो जाएगा 512, एंड लैम्डा टू इक्वल टू आ जाएगा वी डिवाइड बाई 256 के। ठीक है, तो ये दोनों वैल्यू उठा के यहाँ पर पुट कर देते हैं, पुट करते ही हमें आंसर मिल जाएगा। सो यहाँ से इसको सॉल्व करने के बाद ये हो जाएगा v डिवाइड बाई 4, इसमें वैल्यू पुट करने पर v डिवाइड बाई 4, क्योंकि v दोनों कॉमन है, और ये हो जाएगा 512, या ऐसा कर सकते हैं 512 माइनस 256 डिवाइड बाई हो जाएगा 512 मल्टीप्लाई बाई 256 के। ठीक है, सो v की वैल्यू आ जाएगी, और ये इक्वल किसके है 0.16 के। सो v इक्वल्स टू आ जाएगा यहाँ से 0.16 मल्टीप्लाई बाई, ये 4 है, 4 इधर जाएगा तो 4, और मल्टीप्लाई बाई इसकी वैल्यू कितनी आएगी, ये हो जाएगा 512 के। सो टोटल जो वेलोसिटी आ रही है वो आ रही है 328 मीटर पर सेकेंड के। ठीक है, तो ये हमारा आंसर होगा जो कि हमें फाइंड आउट करना था। तो वेलोसिटी ऑफ साउंड जो निकल के आ रहा है इस एक्सपेरिमेंट के थ्रू, वो कितना आ रहा है 328 मीटर पर सेकेंड। तो आंसर में चेक करते हैं, तो जो इसका सेकंड ऑप्शन है 328 मीटर पर सेकेंड, इसका राइट आंसर होगा। ठीक है।
Hello everyone, let's start the question. Question says that equation of traveling wave on a stretched string of linear density 5 gram per meter is y equal to 0.3 sine 45t minus 9x, where distance and time are measured in SI unit. The tension of the string. Okay, so if the wave is traveling, then the velocity. So velocity developed in this case, let's say v is equal to root under t by m. Okay, so we can find out the tension where this t is tension. Okay, and m is the mass. Okay, so to calculate v, what is given in this equation? Only this equation is given, and with the help of this equation we have to find out the v. So if we rewrite the equation, y equal to 0.03 sine 45t minus 9x. Okay, and the velocity is equal to, for this case, will be omega by k, where k is the constant. Okay, and omega is the angular velocity. So here in this using this equation we can find out the omega, which is the 450 in this case, and the k is 9. So velocity can be written as 450 by 9, that is 50. So velocity is 50 meter per second. Okay, now substituting this equation, substituting this value v equal to 50 meter per second to this equation, we can write root under t by m equal to 50. Okay, so if we remove the root, it will be t by m equal to 50 into 50. Okay, and if we take the m to the other side, it will be into m, so t will be this. So we can write 50 into 50, that is 2500 into mass. The mass is given is in gram. Okay, so we will write in kg. This will be 5 into 10 to the power minus 3, and if we solve this, this will be 12.5 Newton. Okay, so the tension is 12.5 Newton. Thank you.
देखो इस क्वेश्चन में मुझे क्या गिवन है, दैट एन ऑर्गन पाइप क्लोज्ड एट वन एंड हैज फंडामेंटल फ्रीक्वेंसी ऑफ 1500 हर्ट्ज, फंडामेंटल फ्रीक्वेंसी 1500 हर्ट्ज, देन द मैक्सिमम नंबर ऑफ ओवरटोन्स जनरेटेड बाय द पाइप विच इज नॉर्मल पर्सन कैन हियर. ठीक है, तो क्वेश्चन मुझे क्या बोल रहा है कि मेरे पास एक ऑर्गन पाइप है जो कि वन एंड से क्लोज्ड है और उसकी फंडामेंटल फ्रीक्वेंसी जो है, फंडामेंटल फ्रीक्वेंसी जो है इट इज इक्वल्स टू 1500 हर्ट्ज. और मुझसे पूछा है कि मैक्सिमम नंबर ऑफ कितने ओवरटोन्स हो सकते हैं जो कि एक नॉर्मल पर्सन हियर कर सकता है. ठीक है, तो इस क्वेश्चन को कैसे करेंगे देखते हैं. तो देखो हम जानते हैं कि एक जो नॉर्मल पर्सन होता है वो कितनी फ्रीक्वेंसी सुन सकता है, अप टू 20,000 हर्ट्ज. ठीक है, या फिर मैं बोल सकता हूँ कि 20 किलो हर्ट्ज तक की फ्रीक्वेंसी एक नॉर्मल पर्सन सुन सकता है. ठीक है, तो जो क्लोज्ड पाइप है उसकी फ्रीक्वेंसी कैसे लिखेंगे हम, फ्रीक्वेंसी ऑफ क्लोज्ड पाइप, इसको मैं कैसे लिख सकता हूँ, v फ्रीक्वेंसी n इंटू वी बाय 4l. ठीक है, और ये जो v बाय 4l है ये मेरी फंडामेंटल फ्रीक्वेंसी है. ठीक है, तो ये क्या आ गया मेरे पास, v बाय 4l मेरे पास फंडामेंटल फ्रीक्वेंसी है, और ये जो है फ्रीक्वेंसी ये है कि मैक्सिमम आदमी कितनी सुन सकता है. ठीक है, तो मैक्सिमम आदमी कितनी सुन सकता है मेरे पास 20,000, maximum frequency a person can hear is 20,000 is equals to n into fundamental frequency, वो कितनी है 1500 हर्ट्ज। तो यहाँ से n की वैल्यू मेरे पास कितनी आ गई, ये आ गया मेरे पास 20,000 डिवाइडेड बाय 1500, तो ये कैंसिल हो जाएंगे यहाँ से और ये बचेगा मेरे पास, ये हो जाएगा 13.33 समथिंग, यानी कि n की वैल्यू आ रही है मेरे पास 13.33, लेकिन n तो मेरा इंटीजर हो सकता है, ठीक है, क्योंकि ये तो नंबर ऑफ हार्मोनिक्स है मेरे, ठीक है, तो n की वैल्यू कितनी हो जाएगी 13 मान लूँगा n की वैल्यू में, ठीक है। तो यहाँ से मैं बोल सकता हूँ कि n की वैल्यू मेरे पास 13 आई है, तो मैक्सिमम पॉसिबल हार्मोनिक्स क्या क्या हो सकते हैं मेरे, ये हो सकते हैं मेरे 1, 3, 5, 7, 9, 11 एंड 13, ठीक है। तो मैक्सिमम n की वैल्यू मेरे पास आई है 13, तो जो मैक्सिमम पॉसिबल हार्मोनिक्स है वो हो जाएंगे ये, ठीक है। तो मैं बोल सकता हूँ कि जो आदमी है वो 13th हार्मोनिक तक सुन सकता है, ठीक है। n जो है 13 आ रहा है, तो ये मेरे हार्मोनिक्स हो गए, तो मैं बोल सकता हूँ कि मैन कैन हियर अप टू 13th हार्मोनिक, ठीक है। और यानी कि ये कितने हो गए मेरे पास, कितने हार्मोनिक्स हो गए ये 1 2 3 4 5 6 एंड 7, यानी कि ये हो गए मेरे पास 7 हार्मोनिक्स। लेकिन मुझसे क्वेश्चन में पूछा क्या उसने कि टोटल नंबर ऑफ मैक्सिमम नंबर ऑफ ओवरटोन्स, तो हार्मोनिक्स मेरे पास 7 है, ठीक है, तो ओवरटोन कितने हो जाएंगे, ओवरटोन हो जाएंगे 7 - 1 दैट इज 6, यानी कि मैक्सिमम 6 ओवरटोन्स एक इंसान सुन सकता है अगर इस ऑर्गन पाइप के अकॉर्डिंग देखा जाए तो, ठीक है। तो इस क्वेश्चन का आंसर हो गया 6, ठीक है। और अगर ऑप्शन में देखा जाए तो ऑप्शन नंबर 3 मुझे मेरे आंसर से मैच करता हुआ दिख रहा है, तो इस क्वेश्चन का आंसर हो जाएगा ऑप्शन नंबर 3। आई होप आप लोगों को क्लियरली समझ आया होगा। थैंक यू।
Hello students, today our question is a granite rod of 60 centimeter in length is clamped at its middle point and is set into longitudinal vibration, and the density of granite is 2.7 into 10 power 3 kg per meter cube, and its Young's modulus is 9.27 into 10 power 10 Pa, and what will be the fundamental frequency of the longitudinal vibration? We have A, B, C, D option is given here. So we have to calculate fundamental frequency here. So the solution of this question is L is given to us, length is 60 centimeter. We can write this in the meter as 0.6 meter here. So this is the length of the rod, and given Young's modulus, that is Y is 9.27 into 10 power 10 Pa. This is the unit of Young's modulus here, and the granite density. So we can write here rho is given to us 2.7 into 10 power 3 kg per meter cube. So we know that velocity of sound in granite is equals to V is equals to under root of Young's modulus divided by density. So from this we can write here our velocity is Young's modulus is 9.27 into 10 power 10, and this is divided by density, that is 2.7 into 10 power 3. So from this we get velocity of the granite on solving this. This is 5.9 into 10 power 3 meter per second here. This is the velocity, and fundamental frequencies is V divided by 2 time of L. So this is 5.9 into 10 power 3, and this is divided by 2 L, that is 2 into 0.6. So on solving this we get fundamental frequencies 5 kilohertz here. So this is 5 kilohertz. So this is the required answer for the question. Now we check which option is correct here. So our option A is correct. Thank you.
देखिए जो स्टूडेंट है वो एक्सपेरिमेंट परफॉर्म कर रहा है रेजोनेंस कॉलम पे। तो डायमीटर ऑफ कॉलम ट्यूब है हमारा 4 सेंटीमीटर, फ्रीक्वेंसी ऑफ ट्यूनिंग फॉक है 512 हर्ट्ज, एयर का टेम्परेचर है 38 डिग्री सेल्सियस, जहां स्पीड ऑफ साउंड है 336 मीटर पर सेकेंड। तो जो जीरो है हमारे मीटर स्केल का वो कोइंसाइड कर रहा है टॉप एंड ऑफ रेजोनेंस कॉलम ट्यूब से। तो जब फर्स्ट रेजोनेंस अकर होगा तो रीडिंग ऑफ वाटर लेवल क्या होगी कॉलम में, ये हमने बताना है। तो देखिए वाटर कॉलम की रीडिंग रेजोनेंस कॉलम के लिए हमें क्या है, देखो लेंथ L प्लस E, फर्स्ट रेजोनेंस मतलब हमारा एक एंटीनोड और एक नोड के बीच का डिस्टेंस लेंथ के इक्वल होगा, यानी लैम्डा बाय 4। ठीक है, तो L क्या आ जाएगा, L आ जाएगा लैम्डा बाय 4 माइनस E। ठीक है, ये आ गया हमारे पास। अब देखिए लैम्डा क्या है यहाँ पे, ये भी निकालना इंपॉर्टेंट है। देखो हमारे को पता है कि लैम्डा क्या होता है, लैम्डा हमारा निकलता है वेलोसिटी v अपॉन फ्रीक्वेंसी न्यू से। ठीक है, इससे निकलता है। अब हमारे पास क्या वेलोसिटी है, वेलोसिटी हमें गिवन है 336 अपॉन न्यू क्या है, न्यू है मेरे पास 512। ठीक है, इंटू 4 आ गया यहाँ से 336 माइनस इसको मैं करूँगी यहाँ से ई। ई क्या है मेरा, ई है डायमीटर, सॉरी एंड करेक्शन। ई क्या होता है 0.3 इंटू डी डायमीटर होता है, तो यहाँ पे मैं रख देती हूँ माइनस 0.3 इंटू डायमीटर क्या है 4 है। ठीक है, तो ये पूरा जब मैं करूँगी, इसको हमने सेंटीमीटर में लिया है, आंसर हमें सेंटीमीटर में निकालना है, इसलिए हम यहाँ मीटर, ये मीटर पर सेकेंड को सेंटीमीटर में चेंज करने के लिए 10⁻² से मल्टीप्लाई करेंगे। ठीक है, तो ये पूरा जब मैं सॉल्व करूँगी ये आ जाएगा 15.2 सेंटीमीटर। तो मेरी रीडिंग आ गई वाटर लेवल की बी, 15.2 सेंटीमीटर बी ऑप्शन है, तो और हम बोल सकते हैं बी ऑप्शन इज करेक्ट, बाकी सारे रॉन्ग है। ठीक है।
Hello students, today our question is an open pipe is in resonance in second harmonic with frequency f1. Now one end of the tube is closed and frequency increased to f2 such that resonance again occur at in nth harmonic. Choose the correct option. A, B, C, D option is given here, so we have to find which option is correct. So the solution of this question is, let the length of the pipe be L. So let length of the pipe is, length is L here, and the speed of sound in air is, speed of sound in air is B. For open pipe, the frequency of second harmonic so we have f1, frequency 1 will become equals to 2 time of velocity, and this is divided by 2 time of length, so this is velocity divided by length here. So this is our frequency 1 here. Let us suppose this is equation 1, and for the closed pipe, the frequency of nth harmonic, so this is f2 must be equals to 2 time of n minus 1, and this is divided by 4L, and this is multiplied with v velocity here. So from this we get frequency 2 is equals to 2n minus 1, and we have v divided by L is this term is f1 here, so we can write f1, and this is divided by 4 here. So this is our equation. Second here, put n equals to 3, in equation 2, we get F2 is equals to 6 minus 1 divided by 4, and this is F1. So this is 5 time of F1 divided by 4, and put N is equals to 5 in equation 1 second. We have to put the values only in second for first and second harmonic here. So this, from this we get F2 is equals to 10 minus 1. 2 into 5 is 10, and this is 4, and this is F1. So this is 9 divided by 4 F1. So we get 2 result here. So now we check which is option is correct here. So for N is equals to 3, our F2 is equals to 4 divided by 5, 5 divided by 4 F1 here, and for N is equals to 5, we have this must be equals to 3. This is the printing mistake here, as we have N is equals to 3, and this must be equals to 5 divided by 4 F1 here. So our option D will be correct here. Thank you.
Hello everyone. So the question is, a closed organ pipe of length L and an open organ pipe contain gases of densities ρ1 and ρ2 respectively. The compressibility of gases are equal in both the pipes. Both the pipes are vibrating in their first tone with same frequency. The length of the open organ pipe is. So in this question we have to calculate the length of open organ pipe, and they have given us 4 options. First option L by 3, second 4L by 3, third 4L by 3 under root ρ1 ρ2, last one 4L by 3 under root ρ2 over ρ1. So now let's proceed with the solution. As we know that velocity of closed organ pipe means Vc is equal to under root Bc by ρ1, as they have given that ρ1 is filled with dense closed pipe is filled with density ρ1, and Bc is your bulk modulus. Now we will find out for closed organ pipe, and closed organ pipe is filled with density ρ2. V naught is equal to Bc ρ2, as they have given that V naught, as they have given that Bc is equal to V naught. Now we will find out the value of first overtone in closed organ pipe. So this will be equal to COP is equal to 3 Vc by 4 Lc. Now first overtone for open organ pipe is equal to 2 V naught by twice of length means L naught. As these both are same, COP equal to OOP. So 3 Vc by 4 Lc will be equal to 2 V naught to L naught. Now we will put the value of Vc and V naught. So this will be equal to 3 by 4 LC B naught by rho 1 BC by rho 1 will be equal to 2 L naught BU by rho 2. B naught and BC will get cancelled out as they both are equal. So as we have to find L naught, so 3 by 3 root rho 1 rho 2, as they have given that this is equal to L. So L naught is equal to 4 by 3 L rho 1 rho 2. This is our answer. So we can say that so option correct. As we can see this option C is correct. So thank you.
The given question is, a sonometer wire resonates with a given tuning fork, forming standing waves with 5 antinodes between the two bridges when a mass of 9 kg is suspended from the wire. When this same tuning fork forming 3 antinodes for the same positions on the bridges, the value of M is, so these are the given options, 12, 5, 12.5 and 25 kgs. Okay, so given is the sonometer wire that is resonating with 5 antinodes. Okay, what are antinodes? The antinodes are the places or are the position where the peak is maximum. Okay, like this. This is our second antinode. This is our third antinode. This is our fourth antinode, and this is fifth antinode. Okay, so like this, and they are between the closed bridge. Okay, so we know that frequency of a standing wave is given as P by 2L under the root T over mu. Okay, where T is the tension, M is the linear mass density of the wire, L is the length of the wire, and P is the number of antinodes. Okay, or we can say the number of loops. Okay, see here are the loops. So in the first case we have 5 antinodes. So let's say the frequency 1, that is nu 1, is equals to P, value of P is 5 divided by 2L multiply by, see, tension in the row will be due to the weight of the hanging on the wire. Okay, so that will be mg, and initially the mass is 9 kg, so that will be 9 into g divided by mu. And in the next case we have the mass is hanging is m, and it is forming 3 antinodes, so nu2 will be equals to 3 by 2l multiplied by m mass, g is the gravity, divided by mu. Further, we have same tuning fork. Okay, so we are using same tuning fork, so frequency must be same. So nu1 would be equal to nu2. So we can say that by equating, we will get 5 by 2l under the root 9g over mu. This must be equal to 3 over 2l under the root m into g over mu. So from here, we can cancel out the common things. That is 2l under the root g by mu. We can cancel out. So we will get 5 into this under root 9 is 3 equals to 3, and this is under the root m. From here we can cancel out 3 also, and further root m equals to 5, so squaring both sides we will get m equals to 25 kg. Hence this is our required answer. So from the given option we will have option D as the correct answer. Thank you.
देखिए इस क्वेश्चन में क्या एक ऑब्जेक्ट है जिसकी स्पेसिफिक ग्रेविटी रो है, इसे हम हंग कर रहे हैं एक थिन स्टील वायर से। तो फंडामेंटल फ्रीक्वेंसी हमारी जो ट्रांसफर स्टैंडिंग वेव फॉर्म हो रही है वायर के अंदर उसकी है 300 हर्ट्ज़। अब हम क्या कर रहे हैं, अब हम ऑब्जेक्ट को वाटर में इमर्स कर रहे हैं सच दैट हाफ ऑफ द वॉल्यूम जो हो वो सबमर्ज हो जाए। तो न्यू फंडामेंटल फ्रीक्वेंसी हर्ट्ज़ में हमें निकालनी है। तो देखो फर्स्ट केस तो ये हो गया हमारा ऐसा कि ये थी एक वायर स्टील की और इससे हमने क्या किया, एक ऑब्जेक्ट को हंग कर दिया, ठीक है, एयर में। तो इस केस में देखो, ये अगर बात करें हम बॉक्स की, तो क्या होगा, देखो हमारा जो टेंशन टी होगी स्ट्रिंग में वो किसके इक्वल होगी, ये हमारा फर्स्ट केस है, ठीक है। केस 1 के लिए हम बोल सकते हैं कि जो हमारी टेंशन टी होगी वो किसके इक्वल होगी, वो मास एम जी के इक्वल होगी। सपोज ये मास एम है, एम जी, और ये टेंशन टी है, ठीक है। तो टेंशन एम टी माइनस एम जी जीरो होगा बैलेंस कंडीशन में, तो टेंशन क्या आ जाएगी, टेंशन एम जी आ जाएगी। अब मास को मैं कैसे लिख सकती हूँ, मास को मैं लिख सकती हूँ रो दे रखी है जो स्पेसिफिक ग्रेविटी इंटू वॉल्यूम वी इंटू जी, रो वी जी लिख सकती हूँ। ये मेरा फर्स्ट केस हो गया, ठीक है। अब फर्स्ट केस की फ्रीक्वेंसी निकाल लेते हैं। फ्रीक्वेंसी का फॉर्मूला क्या होता है, 1/12 टाइम्स ऑफ अंडर रूट टी बाय मास, ठीक है। तो यहाँ पे क्या होगी हमारी फ्रीक्वेंसी एफ होगी कितनी, 1 लेंथ ऑफ वायर 12 अंडर रूट टेंशन क्या है रो वी जी अपॉन मास एम, ये आ गई, ठीक है। अब सेकंड केस पे चलते हैं। सेकंड केस में हम क्या कर रहे हैं, फिगर बनाती हूँ। ऐसी कोई वेसल है जिसमें हमने इस अपने ऑब्जेक्ट को हाफ इमर्ज कर दिया, मतलब v/2 वॉल्यूम जो है वो वाटर के अंदर है, v/2 एयर के अंदर है, ठीक है। अब इस केस में देखिए क्या होगा, इसमें कौन कौन से फोर्सेस लगेंगे, एक तो mg लगेगा नीचे को, टेंशन t है हमारी, ठीक है, और क्या है, और है हमारे पास अप थ्रस्ट, अप थ्रस्ट भी ऊपर लगता है बॉइंट फोर्स, ठीक है। तो इससे क्या आ जाएगा हमारा, हमारे पास टेंशन टी क्या आ जाएगी, आ जाएगी mg माइनस अपथ्रस्ट फोर्स। बैलेंस कंडीशन में t प्लस अपथ्रस्ट फोर्स mg के इक्वल होगा, तो टेंशन क्या आ जाएगी mg माइनस अपथ्रस्ट फोर्स। तो उसमें मैं mg को क्या लिख सकती हूँ, रो वी जी, और अपथ्रस्ट फोर्स क्या होता है, ये होता है कि रो ऑफ, किसका रो लेंगे इसमें, रो ऑफ वाटर, और वॉल्यूम ऑफ लिक्विड डिस्प्लेस्ड क्या है, v/2 है इंटू जी, ये होता है। तो ये आ जाएगा, यहाँ से अगर मैं vg/2 बाहर लूँ तो ये क्या आएगा, 2 रो माइनस रो ऑफ वाटर, ये आ गई मेरी टेंशन। अब इससे मैं फ्रीक्वेंसी निकाल लेती हूँ फॉर्मूले में रख के, एफ डैश। इस केस में, सेकंड केस में मेरी फ्रीक्वेंसी होगी 1/12 अंडर रूट में क्या, vg/2 2 रो माइनस रो w अपॉन m, या मैं 2m लिख सकती हूँ। तो इसको मैं इस फॉर्म में लिख सकती हूँ कि यहाँ से मैं अंडर रूट ऑफ वी जी रो बाय एम ऐसे ले लूँ, तो यहाँ क्या बचेगा, यहाँ बचेगा 2 रो माइनस रो w अपॉन रो, अपॉन क्या आएगा, vg/2 था ना, अपॉन 2 रो, ये आ जाएगा। तो ये क्या होता है, ये पूरा टर्म मेरा 1/12 रो vg/m f था, तो ये आ गया f टाइम्स ऑफ अंडर रूट 2 रो माइनस रो ऑफ वाटर डिवाइडेड बाय 2 रो, ठीक है। ये आ गया मेरा f डैश। तो f की वैल्यू क्या गिवन है, f की वैल्यू गिवन है 300 टाइम्स ऑफ, क्या लिख सकती हूँ मैं इसे, 2 रो माइनस रो ऑफ वाटर क्या होता है, 1 होता है, अपॉन 2 रो, स्पेसिफिक ग्रेविटी ऑफ वाटर होती है मेरी 1, रो ऑफ w मैं लिख सकती हूँ 1, ठीक है। तो ये मेरा f डैश आ गया। ये कौन सा ऑप्शन है, ये अभी हम देख लेते हैं। ये है हमारा 300, ये है हमारा फर्स्ट ऑप्शन, ठीक है। फर्स्ट ऑप्शन में यही बात बोली है, तो हमारा फर्स्ट ऑप्शन क्या है, सही हो गया, और बाकी सारे रॉन्ग, ए ऑप्शन इज करेक्ट, ठीक है। तो ये क्वेश्चन सॉल्व हो गया हमारा।
Hello everyone, let's start our section. The question says a wave represented by the equation y equals a cos kx minus omega t is superimposed with another wave to form a stationary wave such that the point x equals 0 is a node. The equation for the another wave. Okay, in this question we are provided with a wave which has equation y equals a cos kx minus omega t, and it is superimposed with another wave. It is superimposed with another wave to form a stationary wave. The two wave form stationary wave. And it is also given that the point x equal to 0, it is node. A node that formed in a stationary wave is at the point x equal to 0. And we have to find equation for the another wave. So a stationary wave or a standing wave means when a two wave of same frequency and amplitude travels in opposite direction. That is a stationary wave. Same frequency and amplitude. Same frequency and amplitude. Stationary waves are waves which have same frequency and amplitude. Travels in opposite direction. Opposite direction. This is a definition for a stationary wave. And a node is a place in a wave where the amplitude is 0. Amplitude is defined as 0. Node is a place where amplitude is 0. Amplitude is 0. So first of all, let us assume that y2 be the second wave. Let's assume that y2 be the second wave, that is y2 equals plus or minus a cos kx plus omega t. And let y1 be the given wave, that is y1 equals a cos kx minus omega t. In the first case, we are going to assume that the second wave, the another wave is positive. That is the y2, which is given as plus or minus a cos kx plus omega t is positive. That is a cos kx plus omega t. And our given wave y1 is a cos kx minus omega t. We are going to add both these wave, that is y resultant are equals y1 plus y2, that equals a cos kx minus omega t plus a cos kx minus omega t. This equation is in the form of a trigonometric equation, that is a cos x plus y plus a cos x minus y, and their resultant is given as 2a cos x plus cos x cos y, cos x cos y, cos y. And if we consider in this equation, we will get the resultant yr as 2a cos kx cos omega t. We have said that a node is a place where the amplitude is 0. So the given node is at the point x equals 0. That is, when the x equals 0, there is no amplitude. The amplitude is 0, which means the y coordinate should be equal to 0. So when x equals 0 in the first case, that is yr becomes 2a cos k into 0 cos omega t, and y resultant will be 2a and cos 0 will be 1. We will get the y resultant 2a cos omega t, which is not equal to 0. So we'll move on to the next part, that is we will consider y2 has minus of a cos kx plus omega t. This will be our another wave, and our given equation y1 equals a cos kx minus omega t. Their resultant will be y1 plus y2, that is y resultant, and it will become a cos kx minus omega t minus a cos kx plus omega t, and this is also in the form of a trigonometric equation, and their resultant yr will become 2a sin kx into cos omega t. Now we are going to substitute for x equals 0. At x equals 0, y resultant will be 2a sin k into 0 into cos omega t. So y are equal to 2a sin 0 into cos omega t, and the y resultant will be 2. So 2a into sin 0 is 0 into cos omega t. So the y resultant will be equal to 0. That is, so we have said that a node is a place where the amplitude of a wave is 0. That means both x and y are 0. We have find that y2, which represented by minus of a cos kx plus omega t, which is equal to 0. So our resultant wave or the another wave is represented as option C, minus of a cos kx plus omega t. Okay, thank you.
Hello students, here's a question. A tube closed at one end and containing air reduces when excited the fundamental node of frequency 512 Hz if the tube is open at both ends and the fundamental frequency that can be excited is in Hz. So, first of all, the fundamental frequency for the tube closed at one end is, this is a fundamental frequency when the tube is closed, right? And where variables have their usual meaning, right? Now put the value 512 is equals to 512 into 4 is equals to V divided by L. This is first equation, right? Now the fundamental frequency of for the tube closed at one end, right? So we can write V naught is equals to V divided by 2L. This is the open organ pipe fundamental frequency where we put the value V naught is equals to 1 by 2 512 into 4 from first equation, and from the calculation we get 1024 Hertz. This is the fundamental frequency 1024 Hertz. Thank you.
Hello everyone. Let's begin with the question, and in the question it says that a cylindrical tube open at both ends has a fundamental frequency F, and the tube is dipped vertically in water so that half of its length in water. So fundamental frequency of the air column is now. Okay, so we have to discuss both the cases here. Let's say that uh, let's draw the diagram to understand the things clearly. Let's say this is the initial case and here it is. And in this case, here everything is forming in the air. So this is the initial case, and after that, let's say there is, and here we will what we do here, we will pour some amount of water into it. So let's see here. So till here the water inside it. Now initially it says that the tube has a fundamental. Initially it says that a cylindrical tube open at both ends has fundamental frequency f in air. So in that case, for fundamental frequency, if it travels like this, then it will be the case 1. And if we assume that this length is L, okay, so here, as we know, this is antinode and this is also antinode, and distance between the two antinode is lambda by 2, okay. And since the distance between the antinode here is equal to L, so that means lambda by 2 will be equal to L, and from here we get lambda is equal to 2L. Now one more thing, frequency is equal to velocity by lambda. So from here frequency will come out as V by 2L. So this is the equation number 1, and this is the frequency that we have obtained here by using this. And here there is no water. Now after some time there is water here. So in that case the scenario will be like this. Rest is covered here is by water, and only this, because it says in the question that the tube is dipped in water, so that half of its length in water. So here half of its length in water and half is forming a node and an antinode. So half length, that means this length will be L by 2, and the distance between a node and an antinode is lambda by 4. So we can say that L by 2 here is equal to lambda by 4. With that we can say that it's, let's say it is lambda dash, so lambda dash will be equal to 2L. Now again by the formula of frequency is equal to, it is f dash into V by lambda dash, and finally frequency f dash will come out here as V by 2L, and this is equal to frequency of the case when it was in air. Here it is in water and here it is in air. So with both these values, or say this is equation 2, so from equation 1 and equation 2 we can say that the frequency is not going to change. Fundamental frequency in both cases will be same. So with that the answer C, or the option C, is the right answer, that the fundamental frequency is same in both cases. So this was about this question. Thank you for watching.
Hello students, today our question is, in an experiment to measure the speed of sound by resonating air column in turning fork 500 Hz it is used, and the length of the air column is varied by changing the level of water in resonance tube, and the two successive resonances are here at column length 50.7 and 83.9. Which of the following statement is true? ABCD statement is given about them. So the solution of this question is, we have, let N1 be the harmonic corresponding to, let N1 is harmonic corresponding to 50.7 centimeter, and N2 be harmonic to 83.9 centimeter here. So both are consecutive harmonics, so their differences, both are consecutive. So their differences lambda by 2, that is wavelength divided by 2. So from this we can write here wavelength divided by 2 is 83.9 minus 50.7 here. So from this we get wavelength is 33.2 into 2 here. So from this we can say that lambda is equals to 66.4 centimeter here. So this is the wavelength here. This is wavelength, and wavelength divided by 4. This is 16.6 centimeter, and the length of the corresponding mode must be close to lambda by 4, and 50.7 must be close to odd multiple of length 16.6 into 3 here. So therefore 50.7, from this we can say that third harmonic is 50.7 here. So E plus 50.7 is equals to 3 lambda divided by 4. So from this we can say that E is equals to 49.8, and this is minus 50.7. So this is 0.9 centimeter here, and the speed of sound is, this will equals to V is equals to frequency divided by wavelength. So V is equals to 500. V is equals to, we know that velocity is frequency multiplied by wavelength. So this is F into wavelength, that is lambda. So frequency is 500 and lambda is 66.4 here. So this is 332 meter per second here. So this is the velocity. So from this we get the velocity is this, E is this, and we have the this. So now we check which options are correct here. The speed of the sound determined this from this experiment is 332. So this is correct here. The end correction in this experiment is 0.9 centimeter. This is also true here. And wavelength is 16.65 here, and the resonance is corresponding to, this is incorrect here. So A, B, C are correct. Thank you.
Hello students, our question is a horizontal string fixed at a two end is vibrating in its fifth harmonic according to the equation, and we are given with the equation here. Assuming P is equal to, this is pi and it is 3.14. The correct statements are, we have to find which of the following statements are correct. So we start by drawing the wave, and we know that it's oscillating in its fifth harmonic. So we draw it like this. And in the other direction, it will be like this. Okay, it's not an accurate diagram, but still we can manage with it. Okay, so these are two ends, and there will be node at the two ends. So this will be the length of string. Let me draw it like this. Okay, so this will be our L, and we know that the distance between two nodes is nothing but lambda by 2. So this distance will be our lambda by 2. So how many nodes are there? 1, 2, 3, 4, 5. So the total distance will be 5 lambda by 2, and it will be equal to length of string. Okay, so from here we can easily calculate the length of string, and we can easily check our second option, but we have to find lambda, and we are given with the equation. So from equation we can find lambda, as we know that it is our k, and k is nothing but 2 pi by lambda. So our lambda will be simply 2 pi by k, and k is here in meters, and it is 62.8. So we write the value of k, it will be 2 pi by 62.8. So if we put the lambda in the equation, we can easily calculate L. So our L will be 5 by 2 times of into 2 pi upon 62.8. We put the value of pi, it will be 3.14. 2 will get cancelled out. So our L will be, after simplification, it will be 0.25 meters. So we can see that our second option is correct. So it is our answer for second option. So our correct statement will be second one. And if we talk about number of nodes, so we can count it from the diagram. This is our one node, this is our second node, this is third, this is fourth, and our fifth and sixth nodes. So we can easily count the number of nodes, and the number of nodes is 6. So we write number of nodes is 6. So it's not 5. We can clearly see it. So our first option is incorrect. So we put it like this. Now if we check our third option, so our third option says the maximum displacement of the midpoint of string from its equilibrium position is 0.01 meters. So our midpoint of string will be what? It will be L by 2, which is this one. Okay, so these are nodes like this we are putting here. So between in the midpoint of two nodes, it must be a antinode. So at antinode, amplitude will be maximum. We write at antinodes, A will be A max. That is what? In this case, our equation has maximum amplitude what? 0.01. So A max will be 0.01 meters at the midpoint of string, which is true. So our third option will also be true. If we talk about our fourth option, so our fourth option is about what? Fundamental frequency. So we write D part, F is what? Our fundamental frequency, and it will be velocity upon 2L. Okay, so our velocity will be simply omega by K. We know both the values. We know the value of omega from equation and also the value of K. So we put it here. Our omega will be 628 and our K will be 62.8 meters. So our velocity will be simply 10 meter per second. And if we put this in our formula, so our F will be 10 upon 2 into length, which is 0.25. So if we simplify it, it will be 0.5, which is equal to our how much? It will be 0.5, so it will be 100 by 5, which is 20 hertz. So our fundamental frequency will be 20 hertz. So we write it fundamental frequency. But in the option, the value of fundamental frequency is given 100, so it is false. So this is our question and we have completed it. Thank you.
Hello everyone, let us start with our question. In this question, what is given? If the xy coordinate of the corners of a plate are given as to be 0, 0, L, L, 0, L, and there would be 4 point L, 0. Now the edges are clamped and transverse wave are set up. Now if u x, y denotes the displacement of the plate at points x, y at some instant, what could be the possible expression for u? Okay, so we need to check the options. Now what is the situation? Situation is like this. So these are the corners, okay, of the square. Let's say that this is our P, this is our Q, this is our R, and this is our S. So the coordinates would be 0, 0 here, it would be 0, L, and here it would be L, L, and here it would be uh, 0, L, sorry, here it would be L, 0. Here it would be L, 0 because it is lying on an x-axis. Now if we see if we see all the lines, so what are the equations of line or till where x and y would vary? For SP we can say that our y would be equals to 0 and x would be varying from 0 to L. Similarly, this is for SP, then for PQ, this line, our X would be fixed at L and Y would be varying from 0 to L. Similarly, if we check for this line, RQ or QR, for QR, Y would be fixed at L and our X would be varying from 0 to L. Similarly, the last of our line, this RS, for RS we can see that X would be equals to 0 and Y would be varying from 0 to L. Now, we need to check, this is the condition which is given that the edges are clamped. Now, if the edges are clamped, we can see that if edges are clamped, okay, then we can see that the displacement at the clamped portion or at the edges, this would be equals to 0. This would be the displacement at the clamp. Now, what we do, we just check for each and every expression, that the edges, that SP, PQ, QR and RS, whether the displacement is turning out to be 0 or not. So, we write our first expression where U is given as to be A, this cos pi x over 2L, then cos pi y over 2L. Now, this is our A option. Okay. Now, let's check for our HSP. Now, for SP, our y would be equals to 0. Now, if you put y to be 0 into this expression, then our u would turn out to be A cos pi x over 2L. Now, this would not be 0. Why? Because this factor would not be 0 because our L is varying from 0 to L. If we put our value of L from 0 to L, so it would not be 0 for each value of L. So, we say that this is not equal to 0 for the x varying from 0 to L. Okay. So, we can say that this cannot be our option. So, similarly, we check our B option. If we check our B option, okay, in the B option, it is given that our U is given as to be, which I just checked U. So, it is A sin pi x by L sin pi y by L. So, it is given as to be A sin pi x over L and then sin pi y over L. Okay. Now, if we check for SP, for SP we know that y would be equals to 0. So, if you put y as 0, so this term would be sin 0 and sin 0 is 0. So, we can say that our u would be equals to 0. Now, similarly, if we check for PQ, now for the surface PQ, our x would be equals to L. Now, if you put x equal to L into this expression, it would turn out to be sin pi and sin pi is 0, then u would be 0. Now, if we check for our QR, we can say that y would be equals to L. Now, if you put y equal to L, it would be sin pi and sin pi would be 0. And similarly, at the last we check our RS. Now, for RS, x would be equals to 0. If we put x equal to 0, again u would be 0. That means at each and every edges, this is satisfying our equation, then B would be one of the correct option. Similarly, we check for this C option. So, for the C option, now if we check our C option, now there is just a difference of 2 here in the C option. Okay, rest of the thing is same. So, it would be just same type of expression. We just write the expression here and it would be just same. It would be A sin pi x over L and then it is sin 2 pi y over L. Now, if you put similarly, if you put y to be 0 for SP, then this function would be 0. That means u would be 0, exactly same. Now, for x equal to L, if you put x equal to L into this expression, it would be sin pi, which is equals to 0. Then our u again would be 0. Similarly, for QR, if you put y equal to L into this expression, then it would be sin 2 pi and sin 2 pi would again be 0. Similarly, for RS, x would be equal to 0. If you put x to be 0, then u would be 0. That means C would another be the correct option, because for the C, we are getting u would be equals to 0 for edges. That means C is also a correct option. Now, if we check for our D option, now D option is just similar to our A option. Just that here the 2 is coming here. Now, if we just check let us just check in the D option. We just write our D option where u is given as to be A cos, then it is A cos, let's check what is A cos 2 pi x over L. So, 2 pi x over L and then we are having sin 2 pi y over L. Let's check whether it is 2 pi or pi, just pi. It is 2 pi x over L. Now, if we check for this option, if we put our check for the surface PQ, if we check it for the surface PQ, now we know for PQ, x would be equals to L. Now, if you put x equal to L, what expression would look like to be? It would be u equals to, now this L and L would be gone, cos 2 pi. So cos 2 pi would be cos 2 pi would be basically having a value of 1. Now, so u would then turn out to be a sine 2 pi y over L. Now this value would again not be 0. So u would not be 0 for our surface PQ. Okay, that means we can say that our D would be incorrect option. So the correct option would be our B option and the C option. So hope you have understood the solution. Thank you.
देखिए इस क्वेश्चन में क्या है, एक साइलेंडर रेजोनेंस ट्यूब है जो कि ओपन है दोनों तरफ से और उसकी फंडामेंटल फ्रीक्वेंसी है एफ एयर में। अगर हम हाफ इस लेंथ को वर्टिकली डिप कर दे वाटर में तो फंडामेंटल फ्रीक्वेंसी एयर कॉलम की क्या होगी ये हमें बताना है। तो देखिए सपोज करते हैं ऐसा कोई सिलेंड्रिकल ट्यूब्स हैं, ठीक है। देखिए इस क्वेश्चन में क्या है, ये हमारा एयर कॉलम में क्या होगा, ऐसा कुछ होगा। ये डिस्टेंस बिटवीन टू नोड्स या और टू एंटी नोड्स क्या होता है, लैम्डा बाय 2 होता है। तो यहाँ पे हमें अगर गिवन है कि इस पूरे सिलेंडर ट्यूब की लेंथ L है और हम हाफ में सेकंड केस में क्या कर रहे हैं, हम वाटर में डिप कर रहे हैं, तो L/2 ऊपर बचेगी। अब हमें पता है कि डिस्टेंस बिटवीन टू नोड्स और एंटी नोड्स क्या होता है, ये होता है लैम्डा बाय 2, ठीक है। तो मैं क्या लिख सकती हूँ यहाँ से मैं लिख सकती हूँ कि दो नोड्स या दो एंटी नोड्स के बीच में डिस्टेंस है L, तो लैम्डा बाय 2 क्या है, वो L है। तो मेरा लैम्डा क्या आ गया, 2L आ गया फर्स्ट केस का। अब फ्रीक्वेंसी F क्या होती है, ये होती है C बाय लैम्डा, तो ये हो जाएगा C अपॉन 2L। अब सेकंड केस में देखिए डिस्टेंस बिटवीन अ नोड एंड एन एंटी नोड कितना होता है, डिस्टेंस बिटवीन नोड एंड एंटी नोड होता है लैम्डा बाय 4। इस केस में अगर मैं इसकी वेवलेंथ लैम्डा डैश बोलूँ तो लैम्डा डैश बाय 4 हो गया। तो ये है हमारा एक नोड और एक एंटी नोड के बीच में डिस्टेंस, वो है L/2। तो मैं यहाँ से क्या लिख सकती हूँ, लैम्डा डैश बाय 4 कितना है, L/2 है। यहाँ से लैम्डा डैश कितना आ गया, लैम्डा डैश आ गया 2L, ठीक है। और फ्रीक्वेंसी F क्या होगी, F डैश होगी मेरी C अपॉन लैम्डा डैश, ये हो गया C अपॉन 2L, यानी ये F के इक्वल आ गई। हमसे पूछा क्या था, एयर कॉलम की अब फ्रीक्वेंसी क्या होगी, तो न्यू फ्रीक्वेंसी भी ओरिजिनल फ्रीक्वेंसी F के इक्वल ही होगी। तो हमारा ये आंसर आ गया, ठीक है।
Hello students, today our question is, in a sonometer wire the tension is maintained by suspending a 50.7 kg mass from the free end of the wire. The suspended mass has a volume 0.0075 meter cube and the fundamental frequency of wire is 260 Hz. If the suspended mass is completely submerged in the water, the fundamental frequency will become, so we have to take acceleration due to gravity is 10 centimeter here. So the solution of this question is, firstly we can draw the diagram for it to understand it better. So this is our is maintained in the this, so we can, this is our wire, so air is something like this. So in this direction we have force on FB and in this direction we have M, mass into gravity. So tension 1, this is the tension 2 and this is the tension 1 here. So tension 1 in the wire is mg, mass into gravity. We have the M is given to us 50.7 kg here and G is 10. So from this we get 50.7 into 10 is equals to 507 kg meter per second square here, and we have the tension 2 is T1 minus, and this is FB So we can find here FB is equals to rho of water, that is density of water, and this is volume, and this is G here. So from this we get FB's, we know that density of water is 1000, and we have the volume is given to us 0.0075 here, and G is 10, as we have the volume is 0.0075 and density of water is 1000, and we have put the G here. So from this we get FB is equals to 75 Newton. So this is the force on this, and from this we can write here. Now we know that velocity is V is directly proportional to T, that is, and frequency 1, if we take frequency 1 divided by frequency 2, so this must be equals to tension 1 divided by tension 2. So from this frequency 1 is equals to tension 1 is 507 and tension 2 is given to us. So we have to calculate the tension 2 here. So the tension 2 is equals to T1, that is 507, and this is minus FB, that is 75 here. So this will equals to 432 Newton here. So this is our tension 2. So we can highlight here. This is tension 1 and this is tension 2 here. This is tension 2 here. So if we put here 432, and from this we get V2. Frequency of V2 is V1, and this is in multiplication with T2, that is 432, and this is divided by 507, as it will goes in the multiplication, so the it will goes here, denominator will be in numerator, and on solving this we have the V1 is 260 given to us, and this is in multiplication with 432, and this is divided by 507. So from this we get frequency of second is equals to, this is 240 hertz here. So this is our answer for frequency 2, and we have taken V1 is equals to, it is given to us given here. So this is our answer. Thank you.
इस क्वेश्चन में क्या पूछा है, साउंड वेव्स हैं जिसकी फ्रीक्वेंसी है 660 हर्ट्ज, ये नॉर्मली फॉल कर रही हैं एक परफेक्टली रिफ्लेक्टिंग वॉल पे। तो शॉर्टेस्ट डिस्टेंस फ्रॉम द वॉल क्या होगा जिस पे एयर पार्टिकल की क्या होगी, मैक्सिमम एम्पलीट्यूड ऑफ वाइब्रेशन हो मीटर्स में। तो हमें ये निकालना है। तो इसके लिए हम क्या करेंगे, हमें पता है कि लैम्डा क्या होता है। देखो रिलेशन क्या होती है हमारी, c इज इक्वल्स टू न्यू लैम्डा। तो यहाँ से लैम्डा क्या आ गया, लैम्डा आ गया c बाय न्यू। c है हमारा 3 इंटू वेलोसिटी ऑफ साउंड क्या होती है 330। इसको c को स्पीड ऑफ लाइट ना मान लो, इस कंफ्यूजन से मैं v से रिप्रेजेंट करती हूँ। ठीक है, v स्पीड ऑफ साउंड होती है 330, v क्या होता है 330 मीटर पर सेकेंड। तो अपॉन न्यू क्या गिवन है 660, तो ये आ जाएगा 0.5 मीटर्स। ठीक है, तो जो हमारा रेयर फ्रैक्शन होगा वो किस डिस्टेंस पे होगा, ये डिस्टेंस पे होगा लैम्डा बाय 4 के। तो ये कितना आ जाएगा 0.5 बाय 4, यानी कितना हो गया 0.125 मीटर। ठीक है, लैम्डा बाय 4 कैसे आया, देखिए यहाँ से अगर ये वेव चली स्टार्ट हुई तो एक नोड से दूसरे नोड के बीच में क्या डिस्टेंस होता है लैम्डा बाय 4 का, लैम्डा बाय 2 का। ठीक है, हमें मैक्सिमम एम्पलीट्यूड ऑफ वाइब्रेशन देना है। तो मैक्सिमम एम्पलीट्यूड ऑफ वाइब्रेशन के लिए ये मिड पॉइंट आएगा हमारा, ये मिड पॉइंट आएगा। तो इस मिड पॉइंट पे क्या होगा, यहाँ पे हमारा नोड आएगा। दो एंटी नोड्स या दो नोड्स के बीच में लैम्डा बाय 2 डिस्टेंस होता है, और एक नोड और एक एंटी नोड के बीच में कितना डिस्टेंस होता है लैम्डा बाय 4 का होता है। और हमें क्या निकालना था, मैक्सिमम एम्पलीट्यूड। अब वेव यहाँ से शुरू होगी, मैक्सिमम एम्पलीट्यूड किस डिस्टेंस के बाद जाएगी, λ/4 डिस्टेंस के बाद, इसलिए हमारा आंसर आ गया ये 0.125 मीटर। ठीक है, और ये सॉल्व हो गया क्वेश्चन।
Hello students, this is the question ID number 644357651. The question states that a string of the mass per unit length mu is clamped at both ends such that one end of the string is at x is equal to 0 and the other end is at x is equal to L. When string vibrates in fundamental mode, amplitude of the midpoint O of the string is small a, tension in the string is T, and amplitude of the vibration is capital A. Find the total oscillation energy stored in the string. Let's do the solution. So here there is a string which is tied at the two ends. The length of this string is L, and here it is at x is equal to 0 and it is x is equal to L, and it is clear the length between the two consecutive nodes. So here and here there are two nodes, and the distance between the two consecutive nodes are the distance between two consecutive nodes, that is L is equal to lambda by 2, where lambda is the wavelength of the waves which is produced by the vibration. That means lambda is equal to 2L. Now amplitude of the vibration, amplitude of the vibration can be represented as A is equal to A sin kx, where k is the wave vector and this wave is moving in the x direction. So here k is equal to wave vector, and the value of this wave vector is 2 pi by lambda, and lambda is 2L, so that means it will be 2 pi by 2L, and it is k is equal to pi by L. Now this A will be this capital A is the amplitude and A is the amplitude of the vibration. Sin k is pi, that is pi x by L. This is equation number 1. Now when the string is vibrating, suppose at x distance, so this is let us assume a small element of this is dx, and the mass of this small element is dm is equal to mu dx, where mu is the mass per unit length which is given. Mu is the mass per unit length. Now mechanical energy mechanical energy at any distance x, this because of this small element at x of length dx is given by dE is equal to half the mass of this small element, that is dm, amplitude of the wave, that is a square, and the frequency square, angular frequency. So here dm is equal to mu dx, half this will be mu dx, and a is a square, small a square sine square pi x by L, and omega is 2 pi nu square, and this is dE. Now we know there is a relation between the nu and tension, that is we know that is nu is equal to v by lambda, where v is the velocity, and this velocity has a relation that tension in the string divided by mass lambda divided by lambda is 2L, and we have required nu square here. The nu square will be T by mu upon 4L square. Now substitute this value in this equation. Now you will get dE is equal to half mu dx a square sine square pi x by L, and 4 pi square nu square. Now nu square is equal to T by mu, that means dE is equal to half mu dx a square sine square pi x by L, 4 pi square nu square is equal to T by mu upon 4L square. This mu and this mu is cancelled, then you will get, and this 4 is also cancelled. Now dE is equal to this half and a square pi square T divided by L square and sine square pi x by L and dx. Now to find out the total energy in this string, integrate this equation on both sides, then you will get from 0 to L. So it will be E is equal to a square pi square T divided by 2L square integration 0 to L, and it can be represented 1 minus cos 2 pi x by L and divided by 2, and dx it will be E is equal to a square pi square T by 2L square, and the integration of this will be this is x, and cos 2 pi x, that is minus sine 2 pi x divided by 2 pi by L, and integration is 0 to L, and this 1 by 2 can be written as here. So when you put this limit, so it will be L minus 0, that is L, and sine 2 pi L, it will be, here x is L 2 pi L, and it will be 0. So the value of this will be 0. So you will get E is equal to a square pi square t by 4L square into L. Now 1 L to this L cancel. Now the total energy in the string is a square pi square t by 4L. So this is the correct answer, and this is the total mechanical energy which is stored in the string. Thank you. Sorry, there will be by L here. When you substitute this L here, then L to L cancel, then sine 2 pi is 0, and you will get this answer. Thank you.
Hello everyone, let us try to solve the given problem. So the given problem simply state a 3.6 centimeter long vertical pipe resonate with the source of frequency 212.5 Hz. When the water level is at a certain height in the pipe, find the height of the water level from the bottom of the pipe at which the resonance will occur. Now neglect end corrections, right? Let us first try to solve this first part. For that, let us try to draw the diagram. So you can see I have drawn the diagram here. Now this is simply an air column, and air column is resonating with this frequency 2.2.5 Hertz. So let us now assume that this will be the fundamental frequency of this air column. So what is the fundamental frequency of a closed organ pipe? It is simply nothing but V divided by 4L. So we can find out the smallest length of this air column for which there will be resonance, right? There can be more length of the air column. We will calculate that later. So this is simply the smallest frequency or the fundamental frequency of air column. Now, if the smallest frequency is equals to 2 to 2.5 Hertz, that is the smallest frequency of this air column is equals to this frequency, then there may be some other length for which the frequency can be an integral multiple of this frequency. Even then the resonance will simply take place. So let us first try to find out the smallest length of the air column that will give you the greatest height of the water level. This is the main concept. Now if you put the value of n here, this is 212.5, and the speed of sound in air is simply given as 340 divided by 4 into L. If you find out L from here, what you are going to get is simply 0.4 meters. Now, since a closed organ pipe produces odd harmonics, so the other lengths will be simply, first length is L, other will be 3L, 5L, sorry, this will be 5L, 5L, 7L, 9L, and so on. So the first length for which resonance will take place, first this is the length of the air column. Remember, we have to find the height of the water in the pipe. So we will calculate that later. So this is 0.4. If you multiply it by 3, it will be 1.2. If you multiply it 0.4 by 5, this will be 2. If you multiply it by 7, this will be 2.8. And if you multiply it by 9, this will be simply 3.6. Now since the total length is simply 3.6, so we will not have resonance length beyond this, right? So we will not obtain any other resonance length beyond this. So now we can calculate the height of the water corresponding to these lengths. So you can see that the first height of the water will be simply 3.6 minus 0.4, which is simply nothing but 3.2 meters. So when the water is filled up to the height 3.2 meter, then the resonance will take place. And similarly we can find out other lengths. This will be 3.6 minus 1.2. This will give you simply 2.4 meters. And next length H3 will be simply 3.6 minus 2. This will give you 1.6 meters. Fourth length will be simply 3.6 minus 2.8. So this will give you 0.8. This will simply give you 0.8 meters. And then the fifth length of the water column will be simply 3.6 minus 3.6. This will simply give you 0 meters. This is very interesting result. When the height of the water column is these 6 values, then the resonance will take place. So this is the answer to the first part. Let us now move to the second part. So you can see in the second part of the question, some oil is filled up to the top, right? For the total height, the oil is simply filled. This is 3.6 meter. The oil is filled up to the top and there is a hole at the bottom. Now when there is a hole at the bottom, this oil will simply rush out from this hole with the velocity. Now as a result of this hole, water will simply come out with velocity of efflux. Here will be simply, we know that velocity here will be simply equals to under root 2g capital H. That will be the height at any instant. Now what will happen is that the volume of water will simply decrease with time here, and that will be simply equals to decrease in volume here. So we can take the decrease in volume flow rate here will be simply equals to the volume flow rate out, right? This is volume flow rate which is out. Now let us assume that this hole has a small area small a and this pipe has area capital A. Now we know the radius of both, so what we can do is that we can equate the volume decrease in volume flow rate is simply equals to the volume flow rate which is simply out. So this decrease in volume flow rate is simply A into d capital H divided by dt. This will be equals to volume flow rate out is A into velocity v. Now A, we do not know the value of A, so we can write pi into capital R square because we know the radius. This will be dh divided by dt. We need to also put minus sign here because this is decrease in volume, so dh by dt we have to put a minus sign here. So this will be simply equals to area. This is a small area, so this is pi r square into, we can write the velocity here is simply equals to 2g capital H. Now in the second part, what we have to write, we just have to write an expression. So if you cancel out pi and if you put the value of r, capital R and small r, so you can see that the capital R radius of the pipe and the hole are 2 into 10 to the power minus 2 and 1 into 10 to the power minus 3. So if you put capital R equals to 2 into 10 raised to the power minus 2 square into, this will be simply dh divided by dt. This will be simply equals to r square. Now r square here is simply nothing but 1 into 10 raised to the power minus 3 square into, this will be square root 2g into h raised to the power 1 upon 2. We can write it like this. Now if you simplify this equation, there is a minus sign here also. Let me put it here. Now if you simplify this equation, what you are going to get is, you are going to get dh divided by dt with the negative sign. This will be simply equals to, now if you solve these values, you are going to get this value. This will be 5 root 5 into 10 raised to the power minus 3 into h to the power half, and this will be simply equals to rate of decrease in height of the oil. Now what we have to calculate next is, we have to calculate the time interval between the occurrence of first two resonances, right? So in the first case, between the first two resonance, we have to calculate the time period. So what is the main concept? Now we can calculate the time interval between two resonance. So you can see that when the initial length of the water will be 3.2, then there will be first resonance, and when the level of the water will simply decrease to 2.4, then there will be the second resonance. So we can calculate that time period from this equation. So you can see that we can write this equation like this. This will be minus dh whole divided by, we can bring this under root h here, and you can see here the h will simply vary from 3.6 to 2.4. Then this will be simply equals to, this value will be 5 root 5 into 10 raised to the power minus 3 into, this will be dt. Now when you integrate on this side 0 to t, this will give you the time interval between two successive resonance. Now when you solve this equation, when you solve this integral, what you are going to get is, you can see that you will get simply under root h in upon, this will be simply nothing but 1 upon 2, and you have to take the limits. Remember that these limits are in meter, and there is a minus sign here also, right? So this will be simply nothing but, this will be 3.6 to 2.4. This will be equals to 5 root 5 into 10 raised to the power minus 3 into, this will be simply the time period t. So we can write this like this. This will be simply minus 2, and in bracket you can see that this is 2. We can bring this outside, right? And we can take the limits. So this will be under root 2.4 minus, this will be under root 3.6. This will be equals to 5 root 5 into 10 raised to the power minus 3 into t. Now you can see that this is a smaller value and this is larger value, so there will be a minus which will come outside, and this minus will be compensated. And if you solve, what you are going to get is t will be simply equals to 43 seconds. So after 43 seconds there will be the second resonance. So this will be the time period between two successive resonance. So I hope you understood the entire explanation. Thank you.
Hello students, here the question is, the air column in a pipe closed at one end is made to vibrate in its third overturn by tuning fork of frequency 220 Hz. The speed of sound in air is 330 meter per second, and end correction may be neglected. Let P0 denote the mean pressure at any point in the pipe, and delta P0 is the maximum amplitude of pressure vibration. Then find the length of the air column. So here we have to find out the length of the air column. So in case of closed organ pipe, in case of closed organ pipe, as the fundamental frequency is V divided by 4L, in case of closed organ pipe, so the fundamental frequency is V divided by 4L. But in case of open organ pipe, its fundamental frequency is V divided by 2L. But in case of closed organ pipe, it is V divided by 4L. And only odd harmonics are present. In this case, only odd harmonics are present. Like 3, 5, 7. Okay. Here in closed organ pipe, only odd harmonics are present. So the second overtone will mean the fifth harmonic. First overtone is the, so here the first one is the fundamental frequency, then the first overtone, then second overtone. Okay, so here in this case, second overtone means fifth harmonic. Okay, so second overtone means here the fifth harmonic. Okay, so the question says that the speed of sound in air is this, and the P0 denotes the mean pressure at any point, and here it is said that in its third overtone by tuning fork. Okay, so in its third overtone, if second overtone means fifth harmonic, then the question says that in its third overtone. So third overtone means this is the seventh. Okay, seventh harmonic. This is the seventh harmonic. Third overtone means here, because it's all about the odd harmonics are present, so third overtone means seventh harmonic. So here we can write F is equal to for closed organ pipe, F is equal to 7V divided by 4L, which is equal to, as per the question, this is 220 Hz. This is 220 Hz. Okay, so 7V is equal to 220 Hz. Okay, so now let's calculate what is the length of the air column. We have to calculate the length of the air column. So from this we can write 220 is equal to 7 into V. V is the speed of sound in air, which is equal to 330 meter per second. So 7 into 330 divided by 4L. Okay, so from this we can write L is equal to 7 into 330 divided by 4 into 220. Okay, so here finally L is equal to 7 into 330. Okay, so here 7 into 330 divided by, this is 2310 divided by 880. Okay, so 2310 divided by, this is 880, which is equal to 2.6. Here the answer will be 2.6, and hence the length is equal to 2.6. Hence we have to calculate whether it is a meter. It is meter. Okay, 2.625 meter. Okay, so finally length is, that is the length of the air column is 2.62 meter, 625 meters. So here option 2 is the correct one. Okay, this is the length of the closed organ pipe, or length of the, this is the length of the air column. Okay, this is the length of the air column, and from where we found that value, from the third overturn. From the third overturn we found the value of L. Okay, length of the air column, that is 2.62 meter, 625 meter, which is option 2. Thank you.
देखिए इस क्वेश्चन में बोला है कि जो एयर कॉलम है पाइप का वो क्लोज्ड है एक एंड से और ये वाइब्रेट हो रहा है सेकंड ओवरटोन में, जिसकी फ्रीक्वेंसी है ट्यूनिक फॉक की 440 हर्ट्ज। स्पीड ऑफ साउंड इन एयर है 330 मीटर पर सेकेंड्स। एंड करेक्शन को हमें निगलेक्ट कर रहे हैं। और पी नॉट क्या है? पी नॉट हमारा मीन प्रेशर है किसी पॉइंट पे पाइप के अंदर, और डेल्टा पी नॉट क्या है? ये मैक्सिमम एम्पलीट्यूड है प्रेशर वेरिएशन का। तो हमें फर्स्ट पार्ट में पूछा है हमें लेंथ एल निकालनी है एयर कॉलम की, और सेकेंड पार्ट में हमसे बोला है एम्पलीट्यूड ऑफ प्रेशर वेरिएशन एट द मिडल ऑफ द कॉलम क्या होगा। ठीक है, सी पार्ट में क्या बोला है? यहाँ बोला है मैक्सिमम एंड मिनिमम प्रेशर्स एट द ओपन एंड ऑफ द पाइप निकालने हैं, और डी पार्ट में हमें मैक्सिमम और मिनिमम प्रेशर्स एट क्लोज एंड ऑफ द पाइप निकालने हैं। ठीक है, ठीक है। तो ए पार्ट की बात करते हैं। हमारा पाइप कैसा है? ये है क्लोज्ड एट वन एंड। ठीक है, क्लोज्ड एट वन एंड पाइप है, और ये किस में वाइब्रेट कर रहा है? अपनी सेकेंड ओवर टोन में। तो सेकेंड ओवर टोन के लिए क्या फिगर बनेगी? इसकी फिगर बनेगी, ठीक है, तो ये इस टाइप की हमारी फिगर बनेगी सेकेंड ओवर टोन में। तो हम टोटल डिस्टेंस, ये हमारा एल है, लेंथ ऑफ द कॉलम जो हमें निकालनी है। तो हमें पता है डिस्टेंस बिटवीन टू नोड्स कितना होता है? लैम्डा बाय 2 होता है। तो यहाँ से यहाँ तक लैम्डा बाय 2 डिस्टेंस हो गया, यहाँ से यहाँ तक लैम्डा बाय 2 हो गया, तो ये पूरा लैम्डा आ गया। और डिस्टेंस बिटवीन अ नोड एंड एन एंटी नोड क्या होता है? ये होता है लैम्डा बाय 2, तो लैम्डा प्लस लैम्डा बाय 2 आ गया। ठीक है, सेकेंड ओवरटोन के केस में तो ये पूरा लैम्डा, और ये डिस्टेंस क्या आ गया? ये आ गया लैम्डा बाय 4। तो मेरा लेंथ एल हो गई कितनी? लेंथ एल हो गई लैम्डा प्लस लैम्डा बाय 4, यानी 5 लैम्डा बाय 4 के इक्वल। ठीक है, तो मेरे को पूछा था क्वेश्चन में यही कि हमें लेंथ ऑफ द एयर कॉलम निकालना है। अब हमें पता है वेलोसिटी v क्या होती है? ये होती है f इंटू लैम्डा। तो मैं यहाँ से लैम्डा क्या लिख सकती हूँ? v बाय एफ लिख सकती हूँ। तो मेरा लेंथ l आ जाएगा एयर कॉलम का, कैपिटल L से हम शो करेंगे इसे। ये आ गया 5 इंटू वी बाय 4f। ठीक है, तो यहाँ वैल्यूज पुट कर देते हैं। ये हो जाएगी 5 इंटू स्पीड ऑफ साउंड कितनी है? 330 है, अपॉन 4 इंटू फ्रीक्वेंसी है हमारे ट्यूनिक फॉक की 440। ये सॉल्व करके आएगा 15/16 मीटर। ये मेरी हो जाएगी लेंथ ऑफ द एयर कॉलम। ठीक है, ये मेरा फर्स्ट पार्ट हो गया। अब हम बी पार्ट देखते हैं। बी पार्ट में क्या करना है? देखिए, हमारा प्रेशर के लिए हम क्या इक्वेशन लिखते हैं? डेल्टा पी हमारा होता है कितना? डेल्टा पी नॉट कॉस के एक्स इंटू कितना? कॉस के एक्स कॉस ओमेगा टी। ठीक है, ये इक्वेशन होती है हमारी। तो मैं यहाँ से क्या बोल सकती हूँ कि मेरा एम्पलीट्यूड कितना हो गया? ये मेरा एम्पलीट्यूड हो गया। ठीक है, तो हमें क्वेश्चन में निकालना है एम्पलीट्यूड ऑफ प्रेशर वेरिएशन एट द मिडल ऑफ द कॉलम। ठीक है, मिडल ऑफ द कॉलम यानी x क्या हो जाएगा? मेरा x लेंथ हो जाएगी l बाय 2 पर। तो l बाय 2 पर मेरा एम्पलीट्यूड क्या आ जाएगा? एम्पलीट्यूड होता है मेरा डेल्टा पी नॉट कॉस के एक्स। ठीक है, तो मैं इसको क्या लिख सकती हूँ? डेल्टा पी नॉट कॉस के की वैल्यू क्या है? 2 पाई बाई लैम्डा। 2 पाई बाय लेमडा इंटू एक्स क्या आ रहा है मेरा L/2 आ रहा है। तो यहाँ से आ जाएगा डेल्टा पी नॉट कॉस पाई L/λ। ठीक है, इसमें वैल्यूज पुट कर देते हैं तो क्या आ जाएगी वैल्यू, यहाँ पे लेमडा को मैं रिप्लेस कर दूंगी अपना अगेन किससे, लेमडा हो जाएगा मेरा V/F। ठीक है, V/F से, तो ये हो जाएगा डेल्टा पी नॉट कॉस पाई L/F अपॉन V। ठीक है, तो यहाँ वैल्यूज रख देते हैं। एम्पलीट्यूड आ जाएगा एट मिडल, एम्पलीट्यूड एट मिडल, ठीक है, ऑफ कॉलम। ये आ गया हमारा कितना, डेल्टा पी नॉट। डेल्टा पी नॉट तो हमें क्या दे रखा है, मैक्सिमम एम्पलीट्यूड ऑफ प्रेशर वेरिएशन, तो ये डेल्टा पी नॉट ही रहेगा। कॉस पाई, एल की हमने क्या वैल्यू निकाली थी, 15/16 निकाली थी, और वी क्या था हमारा, वी था 330, और हमारा एफ था कितना 440। तो इस पूरे को हम सॉल्व करेंगे, कितना आएगा, डेल्टा पी नॉट कॉस 5 पाई/4। ठीक है, कॉस 5/4 क्या होता है, 1/√2 होता है, तो ये हो गया डेल्टा पी नॉट बाय √2। तो इतना आ जाएगा मेरा एम्पलीट्यूड एट मिडल ऑफ एयर कॉलम। ठीक है, तो ये कंप्लीट हो गया बी पार्ट भी हमारा। अब हम सी पार्ट देखते हैं। सी पार्ट में बोला है व्हाट आर द मैक्सिमम एंड मिनिमम प्रेशर्स एट द ओपन एंड ऑफ द पाइप। तो जो एंड हमारा ओपन है वो क्या है, वो एटमॉस्फेयर के साथ है, तो वो हमेशा उसका प्रेशर में कोई चेंज नहीं आता क्योंकि वो एटमॉस्फेयर के साथ कनेक्टेड है। ओपन एंड ऑफ पाइप ऑलवेज हैव कांस्टेंट प्रेशर, जो कि इक्वल होता है हमारे मीन प्रेशर के, इक्वल टू मीन प्रेशर पी नॉट। मीन प्रेशर पी नॉट, यानी हमारा डेल्टा पी जो होता है इस पॉइंट पे ओपन एंड पे वो 0 होता है, और पी मैक्स और एंड इक्वल टू हो जाता है हमारा पी मिन के, पी मैक्स हमारा पी मिन के इक्वल हो जाता है, और ये हो जाता है पी नॉट। ठीक है, तो हमसे पूछा था सी पार्ट में मैक्सिमम एंड मिनिमम प्रेशर्स, तो वो दोनों हो जाएंगे पी नॉट के इक्वल, जो कि है हमारे को गिवन मीन प्रेशर एट एनी पॉइंट ऑफ द पाइप। अब लास्ट पार्ट देख लेते हैं, डी पार्ट। ठीक है, उससे पहले हमने ये हाईलाइट कर दिया। डी पार्ट में क्या बोला है, व्हाट आर द मैक्सिमम एंड मिनिमम प्रेशर्स एट द क्लोज्ड एंड ऑफ द पाइप। क्लोज एंड पे क्या मैक्सिमम और मिनिमम प्रेशर है। तो देखो, क्लोज्ड एंड की बात करें तो डी क्या होगा, हम एट क्लोज्ड एंड हमारा मैक्सिमम प्रेशर क्या होगा, मैक्सिमम प्रेशर होगा मेरा मीन प्रेशर पी नॉट प्लस एम्पलीट्यूड में वेरिएशन जितना डेल्टा पी नॉट, मैक्सिमम एम्पलीट्यूड वेरिएशन जितना हो सकता है, और मिनिमम प्रेशर कितना होगा, मिनिमम प्रेशर होगा मेरा पी नॉट में क्या माइनस कर दूं मैं, मैक्सिमम चेंज इन प्रेशर वेरिएशन डेल्टा पी नॉट को कर दूंगी। डेल्टा पी नॉट क्या है हमारा, डेल्टा पी नॉट हमें गिवन है हमारा मैक्सिमम एम्पलीट्यूड ऑफ प्रेशर वेरिएशन। तो प्रेशर में पूरे पाइप में मैक्सिमम कितना वेरिएशन आ सकता है, डेल्टा पी नॉट का। तो अगर डेल्टा पी नॉट का मैक्सिमम प्रेशर वेरिएशन अचीव हो गया है तो प्रेशर कितना हो जाएगा, पी नॉट प्लस डेल्टा पी नॉट, ये मैक्सिमम हो जाएगा। और अगर ये मिनिमम प्रेशर निकालना हो तो हम मैक्सिमम प्रेशर को क्या करेंगे, अपनी ओरिजिनल वैल्यू से सब्ट्रैक्ट कर देंगे, क्योंकि एम्पलीट्यूड या तो ऊपर की तरफ पॉजिटिव होगा या नेगेटिव होगा, तो ये आ जाएगा मेरा मिनिमम प्रेशर। तो ठीक है, ये दो चीज़ें हमने निकाल ली और हमारा डी पार्ट भी सॉल्व हो गया एंड ये क्वेश्चन कंप्लीट हो गया।
Question is given, a metallic rod of length 1 meter is rigidly clamped at its midpoint. So longitudinal stationary wave are set up in the rod in such a way that there are two nodes on either side of the midpoint. So the amplitude of an antinode is, this is a 2 into 10 raised to power minus 6 meter, and write the equation of motion of a 0.2 centimeter from the midpoint and those the constituent wave in the rod. So Young modulation of material in the rod is given and density is given. Both hands are free. So firstly here we take a metallic rod of length. Firstly here take a rod of length. Here this is the spoles and here this both hand are free and here this is the midpoint. Here this is the node and here suppose this is the length is the here this length is the 1 meter. The node here and both end are free. So the wave is like this. This is like here and this is so here this is a diagram and here this length is L by 2, L by 2, L by 2. So here firstly we can write in equation we have to given amplitude of antinode. This amplitude of amplitude is given. We can write amplitude at antinode is equal to 2 into 10 raised to power minus 6 meter. Now here Young modulation of a material of the rod means Y is equal to 2 into 10 raised to power 11 Newton per meter square. Now here density rho is given is equal to 8000 kilogram per meter cube. Now here length of a rod is equal to 1 meter. Now here firstly we find speed of the longitudinal traveling wave in the rod. So here firstly we find the speed of the longitudinal traveling wave in the rod. So V is equal to Young modulus and here this is a dash. So here we can write 2 into 10 raised to power 11 upon 8000. That means this is equal to 5000 meter per second. Now here consider A with the amplitude of the wave. Then amplitude at antinode is, so here this is A and this is a center midpoint. And now here we can write this is a, when consider A be the amplitude of the wave, then amplitude at antinode is 2A. Here we can write A with the amplitude of the wave, then amplitude of at antinode is 2A and A value is given 2 into 10 raised to power minus 6 meter. So here amplitude is equal to 10 raised to power minus 6 meter. Now here calculate wavelength of wave. So here wavelength of wave is 2L by 5 because this is a lambda by 2 and here we can write this is a 2L by 5 and here this is a L is 1 and here 5. This will come 0.4 meter. Now here the equation motion at distance x. Here we can write the equation of motion at a distance f from the midpoint will be given by y is equal to equation of motion. This is a y is equal to 2a sine kx sine omega t. Now here we can write wave number is here. Wave number k is equal to 2 pi by lambda and here this is a 2 pi by lambda is 0.4 is equal to 5 pi. Now here angular frequency is omega is equal to 2 pi f and here it is equal to 2 pi v by lambda. Now here we can put the value and find 2 pi and v is 5000. Lambda is 0.4 radian per second. So here it is equal to 25,000 pi radian per second. Now here at x be given is equal to 2 centimeters. So here we can write 2 into 10 raised to power minus 2 meter, and by is equal to 2 into 10 raised to power minus 6. And here the equation, this equation here x is given and omega is given, k is given, so here we can put the value. So by is equal to amplitude, here we can find 10 raised to power minus 6, so here we can put and find this equation at a midpoint. So here we can write 2 into 10 raised to power minus 6 sine 5 pi into 2 into 10 raised to power minus 2 sine 25,000 pi. Here this is a sine 25,000 pi t. Now here the equation at midpoint is come y is equal to 2 into 10 raised to power minus 6 sine 0.1 pi and sine 25,000 pi t. Now here we can write the equation of a constituent wave. So the equation of constituent waves are, so here we can write y1 is equal to a sine. Here this is the because they are moving opposite direction and means wave supermost. So here kx, this is a value, one is a negative, another is a positive. So here we can write sine omega t minus kx, and here y2 is equal to a sine omega t plus kx. Now here we can put the value. So we can write y1 is equal to 10 raised to power minus 6 sine 25,000 pi t minus 5 pi x, and here y2 is equal to 10 raised to power 6 sine 25,000 pi t minus here plus 5 pi x. So this is the solution of this question, guys. Thank you.